How's everybody doing? Cold morning? Yes.
The writing assignment from last week is due March 4th.
The writing assignment from last week is due on Thursday, yes, March 4th. Yeah, the chapter 5 writing assignment. Yeah. In addition, the CPA that I had originally signed was extended to March 4th. However, if you completed it, I just went ahead and assigned full credit. If you have not completed it, please complete that so that I can give you guys full credit. My bad on that CPA for chapter 5. I think if you read the chapter, you could do the problems, but I wanted to do those problems in class as well. So we'll do information like that today. I'm gonna turn it off here. I think in the future, when it comes to CPAs, just to avoid that scenario again, I'll continue to assign CPAs with the reading, but I'll make sure those CPAs are due after the lecture rather than before the lecture from here on out, just in case there are those computational-based problems. Another thing, interim grades are due today. I've already filled them out and submitted them for this class. Your interim grade is very similar to a midterm grade. We just don't give midterms at Indiana State University. We like to do it 6 weeks in instead of 8 weeks in so that you can make any adjustments to your schedule that you might see fit. Maybe save a few bucks with your financial aid package. So that's why we do it after 6 weeks. Your interim grade is based on everything up through last week. So that includes your first unit exam, and it includes your writing. Anything that was due last week was included in your interim grade. So you'll see those pop up probably tomorrow. And when I fill them out, I literally just go to the Blackboard gradebook and look at your grade and I post them. All right. I don't think I gave any Fs in this class. Really, the only time I give an F for an interim grade is if somebody shows up or somebody doesn't show up after like the first day of class. What else did I want to talk about? We're going to start our projects on Thursday. So those of you who were online for that class period a couple weeks ago where we initially talked about projects, or those of you who actually watched the video, know that we are doing projects about gas prices. And I wanted to know what states you were interested in doing gas prices for and what groups you were interested in joining, or if you wanted to work alone. And I've heard from a few people and I've written down a few things. At this point, if you haven't already notified me which state you're going to be collecting data for, I will be assigning it to you at this point. Those assignments will be given to you on Thursday. I will also have all of the variables that you will need to fill out for this project available to you on Thursday. So basically all you're going to do is go online, you're going to look up gas prices for your state. Any given particular week, you're going to fill in the data across the board in this data table that I'm going to provide, and that'll be good to go for a good start. So make sure on Thursday you look at those instructions with regards to the project. I'll also post a little video about it. Questions before I begin today? Yes, in the back.
The chapter 5 writing assignment, have you pulled up? It pulled up into chapter 6.
Okay, and that's fine. That's my bad. I've changed it to chapter 5 on the file name on Blackboard. I just didn't do it on the actual file itself at the title. So yeah, I'll know it's chapter 5 when you submit it, but as long as it's talking about normal distributions, it is the chapter 5 writing assignment. All right. I think you'll notice this week for the actual chapter 6 writing assignment, the file name is real chapter 6 writing assignment. So I apologize for that. Other questions? All right. One last thing before we begin, we did talk about z-scores, and we did briefly talk about the normal distribution table, the z-table, on Thursday. I have added a link to our Blackboard page, and let's see where it is. It is under course materials on the left side menu at the bottom. Under my grades, there should be something that says z-table. So you will always have access to a z-table via that link. On exams, you will be allowed to click that link and look at that Z table. All right. We're going to use that today as well as we calculate stuff. So it might be in your best interest if you did bring your computer today to go ahead and get on Blackboard and bring that Z table up, because we're going to be using it today. Have an example on the board that we're going to work through. This is, I took this from the internet because I apparently don't have enough originality in the morning to do my own, but we have 2,000 freshmen at State University, and they took a biology exam. And we find out that of those 2,000 freshmen, the scores were distributed normally, so there was a normal distribution, with a mean of 70 and a standard deviation of 5. If we remember what our notation looks like for a normal distribution, our notation would look something like this: a mean of 70, standard deviation of 5. And if we were able to, or if we saw a notation like that, and we know that we have a normal distribution, and we can easily draw our normal distribution by drawing a bell curve. And at the center of this bell curve would be a score of what? Very center. What is that score going to be for this scenario? It's going to be 70. It's going to be the mean. The center is going to be the mean in this case. And then how many standard deviations on each side of the mean are we really interested in when it comes to a normal distribution? How many on each side? Up to 3, right? Up to 3. And why are we really only interested in up to 3 standard deviations on each side?
This would be 65, 95, 98 rule.
Right, 99.7 is the last one, and that 99.7 states that 99.7% of all the data in a normal distribution is within 3 standard deviations. So we have really little data outside of 3 standard deviations. All right, so we know that a standard deviation is 5 units long. All right, so that would mean that 1 standard deviation above the mean would be 75, and then 2 above would be 80, and then 3 above would be 85. And 1 below 70 would be 65, and then 60 would be 2 below, and then 55 would be 3 below. So what we have here is a nice normal distribution in context of our problem. All right. You need to know how to draw these. Right? You need to know how to draw these. Now I want to answer some questions. And we answered questions on Thursday that related to the 68, 95, 99.7 rule. And those questions really talked about z-scores that were precisely integer values away from the center, whether they be 1 standard deviation, 2 standard deviations, or above, or maybe 2 below. We were looking at actual z-scores that were integer standard deviations away from the center. But I kind of teased the class a little bit and said, all right, what if we're looking at percentages where our z-score is in between integer values? So let's work on problems like that today. And we'll start with this first problem. I want to estimate the percentage of scores on this biology exam that are less than 67. Less than 67. All right. So if we're looking at our normal distribution, right, 67 is going to be between 60 and 65, or excuse me, 67 is going to be between 65 and 70. It's probably going to be a little bit closer than to 65, so that represents our 67 right there. All right, and we're interested in knowing the percentage of the data that are involved, or the percentage of scores that would be less than 67. So we're looking at all of these scores in the shaded region right here that are less than 67. All right, Now, again, we can't use the 68, 95, 90, 99.7 rule because we don't have a score exactly one standard deviation below the mean. So we cannot use our math-based estimation to go this way. And we don't have a score that is at the mean. We have a score that is between one below and the mean. And we're going to need to use our Z table to do that. All right. Again, I'm going to note 70 is the mean, 65 is one standard deviation below. What we want to do is we want to say, all right, how many standard deviations below the mean is 67? All right, what is this Z-score? All right, what is that Z-score? We know how to calculate Z-scores. We can calculate a Z-score of 67 fairly easily by doing what? 67 minus 70, so our actual data point minus the mean divided by the standard deviation, and that's going to give us negative 3 over 5, which is negative 0.80, I think that's, no, negative 0.60, negative 0.60. All right, so this is our Z-score for 67, and this is telling us that here with the score of 67, we're almost a little over half a standard deviation below the center, right? This is a Z-score of not -1, not 0, but negative 0.60. All right. Now, what do I need to do with this? Well, we bring up our Z table. All right, our table. I've already turned it off once. I'll turn it on one more time, and then I'll turn it off again. And we can, I hate that this one's not. But what we can do is we can take the Z-score and we can look in our table Z, and that table Z literally gives us Z-scores, and based on those Z-scores, the amount of data that is to the left. All right, the table gives us the amount of data to the left, not to the right, not to the left and right, just to the left. All right, so when this comes up, so I don't know if you guys know this, but we used to have auctions where we gave, where they sold all of the old stuff, the stuff that we got rid of or replaced. They would send to central storage and they would have auctions. And so I got in the habit of buying these projectors when they would come up. They would still have a lot of life left, but I get the projector for like 10, 20 bucks. You know, it's like $1,000 projector. Put it in my room, have like a nice 60-inch to 80-inch television display to play games with. It's pretty nice. All right, so here's our table Z, and I'm looking for a Z-score of negative 0.60. So here's negative 2.3. Make that bigger. Negative 0.60. Here's negative 0.6, and here's negative 0.60, negative 0.61, 2, 3. Negative 0.60 gives us a decimal of 0.2743. 0.2743. All right. And this decimal, when multiplied by 100, would give us a percentage of 27.43, and that percentage is the amount of data, in this case, the amount of scores, the percent of scores that are to the left of this Z-score or to the left of this biology score. All right, the percentage of scores less than 67 on this biology exam, approximately 27.43% of all the scores were less than 67. This should make sense, all right? If we were to look at, all right, how many, what is the percentage of scores less than 70? Well, 70 is the halfway point, so 50%. And then what is the percentage of scores less than 65? Well, using our intervals of our empirical rule, that's going to be roughly 16%. So this value should be between 16% and 50%, and it is. All right. Questions on this first problem that we did? No? Okay. And we're going to need to know how to do this because we're going to do this a lot in future chapters. We won't just do scores, we'll do proportions, we'll do a whole bunch of, we'll do means, We'll do a whole bunch of stuff with this moving forward. All right. So what I'm going to do, I'm not going to turn it on again. I'm just going to tell you what the scores are, and those of you who have the table up can verify. And if you're sitting next to somebody with the table, you can cheat and look off of theirs. But let's go the other way. Let's estimate. Let's estimate the percentage of scores greater than 77. Let's look at our normal distribution. We see that 77 is here between. It's here between 75 and 80. It's probably right there. All right, so this represents the score of 77. And we're looking at scores that are greater than 77. So that includes 80, 85, 90, 95, all the way up that way. So we're looking at all the data in this shaded region right here. And we want to know what that value is. All right. Well, we're going to do the same process again. We're going to find the z-score for 77. Z of 77 is going to be what? 77 minus 70, right? Divided by 5. And that's going to be 7 over 5, which is 1.4. 1.40. All right. Now, if I look up 1.40, it's going to give me an associated decimal and percent, right? 1.40 in this table, positive 1.40 gives me a percent or a decimal of 0.9192. All right. But again, this is an estimation of the data to the left of 77, to the left of a z-score of 1.4. This is going to be -1 standard, or +1 standard deviation, +2 standard deviations. Right, this not 0.9192 is an estimation of the percentage to the left. We want to know the percentage to the right. Right? So if we take the totality of 100% everything in the distribution and we subtract what's to the left, what we're going to end up with is what is to the right. So we essentially, in this case, when we're talking about greater than something, we need to take our decimal and subtract it from 1. And that's going to give me what, 0.0808, is that right? 8. Yeah, I think that's right. And that means that 8.08%, or we estimate that 8.08% of all of our exam scores should be greater than 77. Now there is another way to go to look at this when we're talking about greater. All right, we think about how this is a unimodal and symmetric distribution. Let me get that right out of here. We talk about how this is a unimodal symmetric distribution.
Hoffman?
All right, and we say, all right, we had a z-score of 1.4 there. Well, what would be a z-score of -1.4? Well, it's going to be the same distance from 70 to positive 1.4 of a z-score, or from 0 to a positive 1.4, as it is from 0 to -1.4, which might be somewhere in here. This would be a z-score of -1.4. So if I looked at this, all right, the area to the left of this -1.4 should be the same as the area to the right of the positive 1.4 due to symmetry, right? So if we're going the opposite way, we could say, all right, you know, if I want scores greater than a positive 1.4, then I could say that's the same as scores that are less than a -1.4, and I could just flip the sign on my table and look at the negative z-score instead of the positive one. that would basically keep us from having to do the subtraction. All right. If we were to look at a negative 1.4 z-score in our table, the negative 1.4 z-score in our table, negative 1.4 gives us 0.0808. Right. 0.0808. All right. Does that make sense? I got a furrowed brow.
Yeah, makes sense.
Okay. All right. Well, let's look at another one. Let's estimate the percentage of scores between 62 and 72. Estimate the percent of scores between 62 and 72. And 72. So let me erase my distribution here, make it a little bit cleaner again. All right. And we're looking at scores between 62, here's our 62, and 72, here's our 72. Maybe I should have done that in something that is easily seen, a little bit better here. So 62 and 72. All right. We want to know the percentage of scores between those two scores. So we're looking at this data right here. How might we interpret or how might we find that percentage? We're looking at between two scores. Precisely. He's saying that if we find the z-score and the percentage for 72, it's going to give us the percentage of scores that are to the left of 72. And I find the z-score and percentage of scores to the left of 62. If I take this long line and I subtract this shorter line, then what I'm left with is the area between 62 and 72. All right. So we'll first find the z-score for 72, and then we'll find the z-score for 62. Z of 72 would be 72 minus 70 divided by 5, which is 2 over 5, which is 0.4. And then a z-score of 62 would be 62 minus 70 all over 5, which is negative 8 over 5, which is negative 1.60. 1.60, which, yeah, that's fine. All right, 1.60, yes it is. Okay, so now we say, okay, here's our z-scores. This was 0.4. This was a 0.4 here at 72, a z-score of 0.4. And 62 with a z-score of negative 1.6. That makes sense. This should be between negative 2 and negative 1, and this should be between 0 and positive 1. All right, we're going to find the data or the percentage of data associated to the left of both of these marks. So we first start with 0.4, positive 0.4, 0.4 is 0.6554. 0.6554. And then we look at negative 1.6. Negative 1.6 is 0.0548. 0.0548. So the area to the left of 0.4 from here all the way to the left, that area was 0.6554. And then the area to the left of this is 0.0548. If we subtract this from this, we're going to be left with exactly what we want, the area between 62 and 72, the area between a z-score of negative 1.6 and positive 0.4. So we'll just subtract those. And we're going to get, let's see, 14 minus 8 is 6, and then 4 minus 4 is 0, 5 minus 5 is 0, 6 minus 0 is 6. It looks like we have 6006. Or 60.06% of our data should be between those two. Questions about how we got that? All right, well, I have one more. And this one says, what score would achieve the 95th percentile? What score would a student need to be in the 95th percentile? One, two, this should be 3. I can't number right. That should be 4. All right, what score would it need to be in the 95th percentile? Well, we not have to understand what it needs to be or what that percentile is. We have to understand what a percentile is. Not getting any better. And what is a percentile? What does it mean to be in the nth percentile? The 95th, the 99th, the 80th percentile. What does that mean? All right. We're going to say n percent of all scores are at or below this score. All right, in a sense, this means that 100 minus n% are better. All right, so you take the SAT and they say, hey, you scored in the 90th percentile. That means if you take all the scores in that SAT that you took, 90% of them were at your score or poor or below, all right, scored worse than you. 90% scored worse than you. That means you did very well, right? Only 10% of people who scored better. If you scored in the 99th percentile, then only 1% of people scored better than you. So the higher your percentile, the better of a score that you actually have. Now we want to know what score would a student need to be in the need to achieve to get into the 95th percentile. All right, so let's see if we can draw a picture as to what that might mean in this scenario. All right, well, I'm going to erase these scores because they're not necessarily meaningful right now. But we know that to be in the 90th percentile or 95th percentile in this case, we're going to have to be above average, right? Somewhere above average. So we'll just make a marker here somewhere above average and say, all right, everything to the left of that marker makes up 95% of all of our information. Our goal here is to find out what this score is. And in order to do that, we first have to find out what that z-score is. All right. Now again, the z-score tells us the amount of data, or will allow us to find the amount of data to the left of that z-score. So we want to find the z-score that is associated with a percentage of 95. Does that make sense? So we go to our table Z. And this time we're looking in the center of our table. Okay, we're looking at all those decimals in the middle, and we're looking for 95% or 0.9500. This is going to be in the positive section of the z-scores, and I'm looking for 0.9500. And those of you who have the chart out see that 0.9500 falls somewhere between 1.64 and 1.65. All right. All right, the z-score of 1.64 would yield us 94.95%, and the z-score of 1.65 would yield us 95.05% to the left. So somewhere right in the middle, oftentimes what statisticians use is 1.645, the exact center between those two. All right, and that's fine. In this class, I don't care as long as you pick a value that is between that. You can pick 1.64, you can pick 1.65, you can pick 1.645. I don't really care. All right, but we know it's between there. I'll pick 1.645, which is probably accurate, as being the z-score associated with the 95th percentile. But I want the exam score. I want to find the exam score. Well, if we go back to our z-score calculation, remember the z is going to be equal to some particular one, some exact exam score minus the average of all exams divided by the standard deviation. We have a z-score, we have an average, we have a standard deviation. If we plug all those in and solve for this being the score that we need, it boils down to just simple algebra in order to answer this question to find a specific score. So if our z-score is 1.645, we want to find a particular score when our average is 70 and our standard deviation is 5. That will yield this z-score. So we solve for y. We'll multiply both sides by 5, and that's going to give us, that gives us 1.645 times 5. Look who actually remembers calculating. 0.645 times 5, 8.225. 8.225 will equal y minus 70. And that would mean that we add 70 to both sides. So 78.225 is going to be equal to y. That means a score of 78.225 puts a student in the 95th percentile. That makes sense. A student in the 95th percentile. So finding scores, we reverse the process. Finding percentages, we just find the z-score and then we go to the chart. Either way, being able to understand that chart is pretty key. Now, I haven't mentioned this a whole lot during the semester, but if you find yourself struggling with this, guys, I email me, set up a time to meet with me. I can one-on-one, I can go through this with you. We have tutors over there in room 13. Or I think it's 13, it might be 9, I don't know, the one that's right across the hall here, who deals specifically with statistics, and they understand this very well, and they can help you. But we're gonna need, we definitely need to know how to interpret the z-table and find scores as well as percentages from here on out. This is gonna be kind of a big deal. All right. Questions? Comments? You guys wanna go? Yeah, sure. Yeah, let's time. So yes, we'll see you guys on Thursday. So you'll have that right, chapter 5 right assignment due on Thursday. You guys can talk on Thursday.